also do the same with the 5 minutes.
Yeah. So, hello everybody. On behalf of my co-author, David Suok, I'm going to talk to you about computational reproducibility as well as the computational environment. And we are from GASES, which is a social science institute in Germany. And like any good social scientist, we like to define stuff. And so we recently published a paper to define what is computational reproducibility. And we give this, oh, by the way, you don't need to take pictures. There is a URL down there that you can just, you have plenty of time to look at those slides. So we try to define computational reproducibility in 2 sentences, which is, so if you apply the same analysis on the same data, and if the result is reproducible, so you should consistently produce the same answer. And that reproducibility should be able to check by myself as well as somebody else in their own computational environment. So this is the definition, but can we achieve that? So I'm going to give you 2 cases, and then we can study the computational reproducibility of those 2 cases. Okay, this is the first case, dplyr, probably one of the most used R package in the world. And so I have a data set which is very simple, which is ID 112 and then outcome true, false, and then I have a data frame that look like that. So I'm going to ask you, is this our code computational reproducible? So can it consistently produce the same answer? Okay, I will give you 5 more seconds to look at this code.
Seems like it should work.
Somebody say yes. Some say no. Yeah, we create a problem here already. So we are going to. I'm going to dive deep into this. So on my own computer, using the latest version of dplyr, if you run it, it will give you an error. Because it will give you an error. It's saying that, okay, I don't know what is the outcome column, right? But also on my own computer, and I run it, it will give you results like that, which didn't give me an error. Why is that? So the reason is that I have a time machine, and I go back to 2016, and then I have some extremely old version of dplyr, and then I run those code, and then it gives me some results. But if I use the recent version, it gives me error. And then because I have a time machine, so I can also look at the change log of dplyr, and in dplyr 0.5 is introduced a breaking change so that the code does not run anymore. And so coping with this kind of breaking change, we have basically several methods to deal with it. The first method is to rewrite your code, right? So I can just add according to the change log. I just change the code, adding the changing part so that it runs, right? But what if you publish this code in your paper? For example, like in your Lancet paper, you etch this code into the PDF. So you cannot change those code, right? So for that case, you cannot rewrite your code. And then the second method is to install the old version of dplyr, right? So we can just install the 0.43 version of dplyr, and then it should run, right? But the problem with this approach is that dplyr also has its dependencies. If you install it this way, you will just have the old version of dplyr, but other dependency will still be the new version. It may create some problem. For example, when the old version of dplyr depends on some function that also in the dependencies, and those dependencies, we can call them deep dependencies or recursive dependency. I believe this is the term that the POSIT people use. And yeah, this is the second method. And actually, this is the third method, but I put it as a non-method because it doesn't work for this case, which is to use, so previously you can use mrank, but now mrank is no longer with us, rest in peace. So we should use the POSIT public package manager, super mouthful name, so I will just call it P3M from now. And so the method is to create a URL like that, which you can pin a specific date in that URL, and then you change the repo, I mean your default repo, to that URL. And then when you install dplyr by this way, it should give you the period appropriate version of dplyr as well as their dependencies. Why I'm saying that this one is not working for this case is because the P3M has a time limit. So you cannot go further than 2017. But in this case, it's 2016. So if you run this code, it will give you an error. So this is not a method for this case. And then we have the new guy, which is the rm. So the rm, you may know that it creates a log file, and then I will list out all the dependencies, deep dependency, recursive dependency in that log file, and then you can install the packages based on the log file. And the newest version of rm introduced the checkout function, which also using the date-based pinning of the packages, which is, as you can imagine, using the P3M. So it has the same problem. So it is not a method for this case because, yeah, you cannot go back further than 2017 October. So you can just add this one. So we studied the first case. This is the brief summary for the first case, which is the computational reproducibility is dependent on the computational environment. As you can see from the dplyr example, I run it in two different computational environments. It gives you two different results. And then the dependencies should be best tackled or handled by the time-based pinning using P3M or rm. And if you use rm, it also generate a log file. But unfortunately, for the dplyr case, this one doesn't work because P3M has this limit, which is the date-based limit, which cannot go any further than this one. But if you have a new project, P3M is a good solution to this kind of problem. So we have the second case now. So we're going to the second case. By the way, this is from a bot. There is a bot on Mastodon that just tweet out memes with a picture and then saying for compatibility with S. So yeah. And yeah, we have another code snippet here. So I will ask you the same question. I will give you 10 seconds to look at this code. Do you even recognize this code? Is this R? Yeah, one of my colleagues look at this code and say, "Oh, you make a mistake." So, yeah. So again, on my own machine, and when I run it, it will give me an error. And the partial solution, you can look at it yourself. There's a help page saying base defunct. Yeah. For this one, the problem is more complicated. For example, you cannot use the P3M or the RM for this. Not least because of the date, but also it is related to the base, I mean the R base. And for example, you cannot use RM to pin the base because the Unix time function is from base. And yeah, you cannot create a log file that log a particular base function. And the methods too is to use Docker, or more specifically using Walker, which is the R-based Docker images. And if you run that one, so Docker/R version 3.0.0, it will give you an R console, which is R3.0.0, and then you run it again. Okay, the Unix time works, but for the underscore one, it's still not working. And then if I want to go one version further, so if you want to do 2.15.3, it's no longer working because the Walker team doesn't provide you any image older than R3.0. So for this case, Walker will not help you again. So this is a summary for the second case. The first point is the same, which is the computational reproducibility is also dependent on the computational environment. But in this case, it's not about the R package, but about the programming language itself. So the programming language will evolve. So it will also create something that is breaking. And Docker or container technology is what we can use to tackle this kind of problem. But for this case, Docker has this limit too. So it can only go back as far as R3.0. But yeah, if you have question about it, I would say that those R3.0 code images are not very useful anymore. And if you want to know more, you can ask me in the Q&A or whatever. So we propose our own solution, which is called rank, or if you're German, it's rank. So it's available on CRAN already, so you can install it using install package or using install GitHub. I would say the latest version is way better than the version on CRAN. So if you want to try it, definitely use the GitHub version. And we provide these features. We use the date space cleaning like the P3M. We also generated a container image. We support all major repository, CRAN, bioconductor, GitHub, whatever. And then one very tedious thing is that when you install R packages is those system dependencies. Rank will resolve those system dependencies automatically and then install those system dependencies. And the technology depends on RHub, CRAN, bioconductor, and GitHub, but it doesn't use P3M for some reason. And then it works very well with RN, but the most important feature is that you can go back to 2001, which is we are talking about the period of Tony Blair or Bush 43 or something like that, and even before the 9/11 attack. Okay, we want to move it even further. So we are trying to thinking about how do we do it reproducibility. But yeah, currently it's still at R1.31. So for the usage, it's actually not that difficult, where the package only have two major functions. The first function is called resolve. So you can just tell the functions which package you want to resolve, as well as the date. If you don't want to specify the package, you can just put the path to your project. It will scan all the packages used in your project and then do the resolve for you, and then it will resolve all the packages used at that specific date. And then the result is a dependency graph, basically. So it will tell you, for example, in this case, dplyr at that specific time point, the version was 0.43, and then it has 7 dependencies, and then it will also resolve the period appropriate version of those dependencies. And then you can use another function which is called dockerize to generate the information that you will need to create the Docker image based on the dependency graph that you generated, and then you just put in the output directory. It will be a directory, and we recommend you to use the cache, so it will also cache all the things so that it can be reproducible. So what will be inside that directory? So it will have the root file system of Debian, and then it will also download all the source package of those R package that you will use, as well as the R source. So it will just compile R and then just install all the R packages in the Debian environment, and then it also has the Docker file as well as the README file. And in the README file, it will tell you how to use this directory. So if you are not so familiar with Docker, it will just guide you through how to install Docker, how to regenerate the image and things like that. So it's really nice. And then it's also have a Docker file. And in the Docker file, it will install all the system dependencies, as well as the compile the version of the R that is appropriate for you, and then also install all the R packages. And in the README, it's also telling you how to build the Docker image and then launch the container. And yeah, if you launch it and then run the code from case 1, run. And this is the second case, so I pin it to 2002, and then do the same thing, and then run it, it runs. By the way, if you still don't have no clue what the underscore is, the underscore actually is the assignment operator.
Very old.
Long gone.
Long time ago. Yeah. And there are many features that I have not demoed in this presentation, but if you are interested, you can read our paper. And there are some upcoming features which we will push to CRAN very soon, which is this AppTainer support. So you don't need to use Docker. You can also use AppTainer, previously known as Singularity. And then we will have other features, but they are not so important. And the summary. So I think you will know what my first point is. The computational reproducibility is dependent on the computational environment. And then there's several solutions to this. You can use P3M or RN if your project is after 2017, but it only keep track of the R packages. Use Rocker if your project is newer than R3. Use Rank for everything else, or all other things. So this is the end. Thank you.
So much for nice presentation. I'm sure there's a couple of questions. Maybe let's start with Reinhold.
Thanks, very nice working. What caught my eye was, which version of Debian do you depend on?
Yeah, it depends on the R version.
Oh,
So,
so you go back.
Yeah, I go back. So it's
Okay.
I think it's some of them will based on the R version, we will install a period appropriate version of Debian. So it's I think 7, 8 or something 6 or whatever. So
Yeah, whatever.
yeah.
Cool. Yeah, you want to mix.
Yeah, so actually I have questions. First, you mentioned the interoperability with RAMP. Could you elaborate on that? And also, if that means that you are recommending not to use RAMP anymore.
The interoperability, there's 3 aspects, I would say. We just use the RN to do the project scanning, which is 1. Second is that we support the log file we can pass the log file from using Resolve, and then also doing the same Resolve to get all the period appropriate version of the R package. The first thing is that we adopt the package reference standard created by I think it's a collaboration, but mostly from the POSIT people. So they provide a standard to refer to different kind of R package. For example, like CRAN, : whatever. So it is talking about the CRAN package. So we adopt this standard as well. So when we design this package, we have the interop in mind. So we support actually a lot of things. For example, like not only RNs, but also for example, like the session info output, we can also support that. Yeah.
So do you recommend to use RAMP or not?
I actually recommend you to use RN, but if you are doing some kind of archaeological work like we do, so you may use rank.
Okay.
Yeah.
Thanks for the presentation and for the trip to memory lane here. I have 2 questions. So you're actually using an old Debian version. This comes with old compilers, obviously. So does Debian really maintain repositories 20 years old?
Yeah. So they have the archive. They have the archive repository. So if you change the source to the archive, then it will just go to the archive.
Okay.
Yeah.
And so my question is, have you actually seen, going back 20 years, a case where this wasn't enough, where some differences in the CPU or something caused analysis to behave differently than they were recorded with?
Yeah, so unfortunately, I can only deal with the software layer here, but there are some real cases like the randomizer, the R randomizer changes and stuff like that. But these things are not related to the But there's something like the 32-bit or 64-bit operating system, it would also create some differences, but we cannot do anything about those kind of discrepancies, at least for this package.
Yeah. Okay, and then 20 years is a lot of time. What is the actual horizon in your field? What would be the ideal for how long would you like your analysis to be preserved and reproducible?
Yeah, because we want it to be reproducible in 20 years.
20. This is the goal.
Yeah.
Not 50.
No.
Okay.
For our goal is 20, so we want to go back 20 years.
20, but
Yeah,
that's
this you already
really a lot.
achieved.
Yeah.
Yeah,
And
yeah.
it's amazing. Well, so I had a similar exercise. If I had known this, I would have definitely used it because compilers and everything changes.
Just a remark, I'm an ARCOR member and I've been doing really the archaeology thing. I have still running on this computer versions for pre-10. But anyway, but it's fantastic. I mean, really want to applaud to your project and success.
Thank you. Yeah.
Any further questions for anyone?
Thank you.
Okay, cool. That's